Hi, welcome back to Newton Chemistry. This is Ideal Gas Law Lesson B. Given 1 atmosphere at 0.0083 moles at 298.15 K, what is the volume of the gas? Okay, so now we know this is an ideal gas law because we have moles. That's important. If you see that in there, you know it's ideal gas law. Okay, so we're going to go ahead and set this up. And let's write this out. So we got PV equals nRT. So just like in all the other laws, we're going to set this up PV, nR, and T. Okay, now the pressure is 1.0 atm. The moles are 0.0083 moles. The volume is what we're looking for. The R value is 0.0821 liters times atmospheres over moles times Kelvin, and our temperature is 298.15 K. So now we're going to isolate for V. V equals nRT over P. Pretty simple, isn't it? It really is. It's not that bad. Okay, so now what we're going to do is we're going to plug in our known values. So V equals 0.00831 moles, okay, times our gas constant, 0.0821 liters times atmospheres over moles times Kelvin, times our temperature, which was 298.15 K, divided by our pressure, which was 1.0 atm. ATMs cancel, moles cancel, Kelvin cancels. That leaves only liters left. So V equals 0.20 liters. Pretty cool, huh? Let's look at another problem. Okay, in the second problem, see here, now we're given information, right? And it's not in like some story, like normally you've been picking out with Boyle's Charles, Gay-Lussac, combined gas law. We could put it in a story, but in this case we're not going to do that with this one. So given the information, well, got two of these in there, that doesn't help out a whole lot. Given the information below, what is our pressure? Need an English lesson of the gas. Okay. Well, I'm a chemist, not an English teacher. Okay, anyway, so let's set this up. So we know that PV equals nRT. So we're looking for P. So P equals nRT over V. Okay, good. That's going to be easy. So we're going to go 0.00801 moles times R, 0.0821 liters times atmospheres over moles times Kelvin times temperature, which is 311 K, divided by our volume, which was 0.602 liters. So liters will cancel out. There they go. Moles cancel out. There they go. Kelvin cancels out, leaving only atmospheres left. So P equals 0.34 atm. This is going pretty good. All right. So now, let's look at one more problem. And this time we're going to write this problem out. So here comes our next problem. Okay, in this final problem, if you have 2.15 moles of oxygen gas in a cylinder at a pressure of 500 atmospheres in a 30-liter tank, what would the temperature of the gas be? Okay, so let's set up PV equals nRT. How do you know it's a ideal gas law? Well, look at that. You've got moles. That's how you know. All right, so let's get this to business here. Okay, so what we're going to do is we'll set up PV, nR, and T. Our pressure, of course, is 500 atmospheres. It's a lot of pressure. Our volume is, of course, 30 liters because it's the size of the tank. we have 2.15 moles of this oxygen gas. Our R value is 0.0821 liters times atmospheres over moles times Kelvin. Can that R value change? It can if you use something other than atmospheres. And our temperature, we have no idea. So let's go ahead and isolate for T. So it's going to be PV over NR. So T equals 500 ATM times 30.0 liters divided by 2.15 moles times our R value, 0.0821, of course, liters times atmospheres over moles times Kelvin. So let's see here, our moles will cancel out, our atmospheres will cancel out, all right, and our liters will cancel out. So now T, after let's do the math here. So we'll take our handy dandy calculator, of course. 500 times 30, 0. That gives me a pretty big number. That's like 15,000. And again, we're looking at K here for temperature. And then on the bottom, we're going to take 2.15 times 0.0821. That's going to be 0.17. Let's just call it 0.18 because it's 0.176. So our temperature is going to be 15,000 divided by that number, divided by 0.18. The temperature is going to be 83,333.33 Kelvin. That's pretty darn hot. Well, listen, guys, we'll see you back here at Moose and Chemistry. You guys be snarly and you be cool. Talk to you later.